Okay, now I'm going to do a different example. This one also came from our classwork. Sorry, I've got my alarms going off. Okay. This example is about a taxi. Okay. So in this example, I can take taxi 1. Okay. Taxi number 1 costs $1 per mile plus a $5 flat fee just for getting in the taxi. Okay. Taxi 2 costs $2 per mile plus a $3 flat fee. Okay. So if I'm going to describe these using equations, taxi number 1, my total cost y would equal $1 per mile plus my flat fee of $5, right? Taxi number 2, my total cost would equal $2 per mile. Sorry, it is late and my tongue is not working. Plus my flat fee of $3. Okay, so for both of these, y equals total cost and x equals number of miles. Okay, so these are my variables. Okay, so now as I look at this situation, I've got a few options I could work with here. I'm going to look first at graphing because these are small enough numbers that I could maybe make that happen pretty reasonably. So I'm going to create my coordinate plane. Tick off some sort of scale here for my x and y axis. Okay. And let's start with y equals 1x plus 5, also known as just y equals x plus 5. All right, that's got a y-intercept of 5. Right, there's my b value. Okay, 0, 5. And my slope is just 1 over 1, up 1 over 1. There's another point. If I want to keep going, up 1 over 1. Okay, so I'm going to draw that one there as y equals x. Okay. Then the next one, y equals 2x plus 3. I've got my y-intercept at 3. Okay. But this one has a slope of 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. Okay, so this one looks a little more like this. Okay, so there's my y equals 2x plus 3. Okay, so I've got y equals, oops, this one was supposed to be y equals x plus 5. Let me clean that up so that's a little clearer. This one that I drew here, this was my y equals x plus 5 line. This is my y equals 2x plus 3 line. And if I'm looking for the solution, you probably saw it as I was drawing. It looks like it's right here, graphically. Okay, there is a single point of intersection. All right, it would appear to be at 2, 7. Okay, and what that would say, what does that mean, is that when I am taking that taxi for 2 miles, the cost is $7 regardless of which taxi I take. Okay, so that's kind of my maybe break-even point, where it really doesn't matter which one I take. right? I want to take taxi A, I want to take taxi B. If I'm planning to go for about 2 miles, it makes no difference, right? Again, X is number of miles, Y is total cost, okay? But if I'm going to go, let's say, 4 miles, right? X is 4 miles. Well, if I go up to my lines, the one with the lower cost would appear to be the one where we have Y equals X plus 5. That's taxi 1, right? Because if I go up to taxi 2, that's a higher cost. Okay, so I could make a decision like that using this view. On the other hand, if I chose to take, to go only 1 mile in my taxi, right? Well, if I look at the first line I hit, that would appear to be the Y equals 2X plus 3 line, right? Y equals 2X plus 3 is taxi 2, okay? So I would say if I'm going greater than 2 miles, okay, here's 2 miles. Doesn't matter which one I take. They both have the same X and Y value there. Greater than 2 miles, I'm going to want to take taxi 1. Oh, I lost my light. Please hold. Okay, this is what happens when you work late at night. Anyways, if I'm going greater than 2 miles, right, Y equals X plus 5 is cheaper. So take taxi number 1. Okay, taxi number 1. Okay. If I'm going less than 2 miles, okay, like 1 mile, well, Y equals 2X plus 3 is cheaper. So take taxi number 2. Okay, so I can kind of see that graphically here. It's very easy to make those decisions. All right, let's look at a different method. Okay, so that was graphing. Let's take these two equations and instead, let's use substitution. Okay, so we're going to look at substitution. So I've got Y equals X plus 5. I've got Y equals 2X plus 3. Okay. Now, given that I have these written in slope-intercept form, that's kind of easy to do, right? If I look at Y equals X plus 5, that's kind of the simplest definition of Y I have. So I'm going to use it. Y equals X plus 5. I'm going to let X plus 5 stand in for Y in my second equation. This way I'm kind of connecting the two equations, right? We want a value of X and Y that satisfies both. I already know in this equation Y is X plus 5, right? So let's use that here. So instead of Y equals 2X plus 3, I'm going to say X plus 5 equals 2X plus 3. Right? And now I work this like I would any algebra equation. Maybe I'll bring my X's together since there's nothing I could combine or simplify. I'm going to bring my X's together on one side of the equation. I'll bring my constants together on the other. And I find X equals 2. Well, that sounds familiar from our graphing exercise. So if X equals 2, I'm going to pick one of the equations from above. I'm going to again go with the easiest one here, Y equals X plus 5. And I'm going to put in that 2 for X, and I get Y equals 7. So what's my solution? If I travel 2 miles, my total cost is 7. That makes both equations true. That's exactly what we got way up here. 2 miles, $7 of cost, doesn't matter which taxi I take. Okay, so that's substitution. All right. Now, let's look at elimination. Okay, elimination. Well, I've got Y equals X plus 5. I've got Y equals 2X plus 3. Again, fairly easy to eliminate, right? I'm going to actually subtract this equation from this one. Why can I do that? Well, here's my original equation. I can add or subtract the same thing from both sides. All right, and I'm going to choose to subtract the same thing from both sides, right? These are equal, so I can subtract them from both sides of this equation. Okay, so let's see what that looks like. Just subtracting here, okay? Sometimes you'll see it written like this. So y minus y, well, that's nothing. And I need to show that it's nothing, 0. Okay? X minus 2x. Well, that's just negative x. Okay? 5 minus 3. Well, that's just 2. Okay? So since I've got 0 equals negative x plus 2, I'm actually going to make this a little neater looking and add x to both sides. Negative x, positive x is gone. I get x equals 2. Well, what am I going to do with that? Same sort of process as I had over here. I've got a value of x. I'm going to take one of these equations. I like this y equals x plus 5 just because it's a little simpler. I'm going to let that value of x be substituted. I get y equals 2 plus 5. No surprise here, y equals 7. What's my solution? 2, 7. Okay? So here you can kind of see all three methods very nicely. We could have done that in the other situation with the tickets for the homecoming dance, but I think that would have been a little harder. We might have had to use our graphing calculator or had to estimate and play around with different scales, and here we really didn't need to do that. Okay, hope you find that helpful. Thanks, bye.